MQA Certification UK Ltd, presented, Lean Six Sigma Green Belt Training Day 4.
Here there is a cut here. So this cut is not so expensive. But what it is solving customer problem that the SIM card cannot be put reverse direction. See, here what will happen? Only customer will put it wrong, right? But simple and cost cutting is there. Like it is not so much. Only a simple change in a die will cut this slot. So there is no much involvement. Now implement the solution. All the solutions have to be implemented. There is a concept called horizontal deployment. Do you people understand that? Horizontal deployment. Are you aware of horizontal deployment?
No, sir.
See, when we take
No,
any
sir.
action now, so it is like we have solved the problem for one product, right? But when there are other family of related product, we can take the same action on the other product also. So what is it called? Horizontal deployment. One family, second family, third family of products. So the family here is SKU. Like suppose we are making one part, one type of brakes. So we have done Kaizen in one type of one for one car model. Then we should not stop here. We should implement the solution in all the car models, right? Because today defect is here, but there is no assurity, right? The defect can occur in other car model also. So that is called horizontal deployment. You can say like example, one type of machine, if I make a fixture for one type of machine, I can implement same idea in other fixture also. So this will help to solve the problem among the family of the products. So hope I am clear on this. Hello.
Yes, sir.
Okay. So now this is applicable for all the solutions. Like we should not think that we have implemented it in one place. We have to implement wherever it is applicable. If same type of product is there, we can implement in other product also, which is having same properties, same characteristics. That is horizontal deployment. Whenever you do any like corrective action report, in the bottom there will be horizontal deployment. There you have to mention that these actions are taken for this product also. So one action and applicable for 10 products, do it for 10 products and eliminate that defect in other 10 products also. That is basically horizontal deployment. Now mistake proofing POCO, like we can see the example, like automated shut off on iron door. Okay. Grounding fault circuit breaker for bathroom and outside electric circuits. Pilotless gas ranges and hot water heaters. Child-proof caps on medicines. You know, there when the medicines, there is a cap. Okay. So that is caps is only for like child cannot open it. Otherwise, what will happen? Child will open it and drink the medicine without any knowledge. Now, a simple example of mistake proofing is in our Excel Word. We have spell check. So what does it does? We on the function, it will auto correct. It will ask for correction of the spelling mistakes. Second, so few example is like whenever we delete any file. So before deleting any file, what does computer laptop ask us? They ask us now whether to, they repeat the steps. They ask, are you sure you want to delete? So this is also okay because sometimes we mistakenly delete the file. So this is second step of action where we will understand that whether we are deleting or not. Okay. So this is like okay. One okay was like in a punching operation. So you know there are foot operated switches, there are hand operated switches. So there was one Poco-AK where the controls were two-way. Like you have to on with the hand also, you have to switch on with the foot also. So this is also Poco-AK. Like without simultaneous oning of hand and foot, the machine will not start. Why this is required? Because sometimes we are in a different mind. So when we are using our leg, we one part of our body, we don't think. But when we are using our two part of our body, our focus comes back. Like when we have to operate switch on the machine with hand as well as with leg. So what will you do? One hand will go to manual switch, other my foot will go to foot switch. Then what will happen? I am on the machine, available on the machine. I am not like here and there. So I will operate it properly. Sometimes it may happen that my hand is on the machine. One hand is on the switch, one hand is on the machine. Then that condition, my hand will be safe. In factory, like dual palm buttons and other guards on the machinery. Now in machinery, like in most of the rotating parts, there are covers and guards. You must have seen. So what is that? That is safety mistake proofing. Like nobody should touch. Nobody will touch the rotating parts. There are different types of sensors available. Like there are photo sensors available which will detect the human parts. Like photo sensor, if the hand is going inside the machine, the photo sensors will detect and it will not start the machine. This is also mistake proofing. Generally in the press shop where the tool is coming, where the forging, machining, wherever there is moving parts, there it is required. Now one more pocket is used in safety is uh, we have like lockout tagout system. You know lockout tagout? Well, lockout tagout is one
Yes.
of the
Yes,
important
sir.
safety kaizen. So what is there tagout? Whenever an electrician want to do work in the panel, what he will do? He will switch off the machine, switch off the panel section, and he will lock the switch with the lock and key, and he will keep the key with him. Now what will happen here? What will happen here? Unless see what will happen here, panel is another position, on off switch is in another position, and panel is in different way. So he cannot handle both simultaneously. So what he is doing, he is locking the on off switch. It means in his absence, nobody can on the switch because he is working on the panel. So lockout tagout is there. Some of the things is like when it is like you must have seen the lifts on the residential and commercial lifts. So there are like 5 persons are allowed in the lift. Now what will happen if 6 person enters? When the 6 person enters the lift and the capacity is 5, the lift will not start. You have noticed this? This is also a safety poco. Okay. What will happen here? Because the lift has a capacity of 5, it should not be used for 6 because it will have load on the motor and belt, like the rope. There may be chances of damage to the lift and rope may break or something, some accident can happen. So these kind of POCO are locally available and like we are implemented in the real life. One of the POCO, you know, when they there are on flyover, we have seen some of the flyovers where there are like when the on entry point there is a 7 feet high stopper is there. So what does the stopper does? The big trucks who are not supposed to run on the flyovers cannot enter. That kind of POCO is there. Okay. Then one of the POCO is barcoding. Now what is barcoding? Barcoding is like we are giving the detail in the barcoding and barcoding is generated. Now what will barcoding do? Barcoding will identify and give us the information based on the barcode generated. Okay. So this kind of like barcoding check is there. Now example I can see there was some like suppose there is some one incident was there. Just is a story of incident like somebody has poisoned someone. So what happened? One person has given poison to his friend. Unfortunately, he left the bottle at home. So what happened? The bottle was having barcode. So how the police tracked him? Police found the poison bottle in his room. Then what did police do? Police scanned the barcode. They got the information from where the poison is purchased. Now what they do? What did they do next? They went to the departmental store and then they scanned the barcode, and from the barcode they got the information who purchased this poison bottle. So this way it is very much important. Like nowadays everything is there, that all the transactions are tracked to avoid any criminal activities. So POCO is very important in many cases. Barcoding gives us information of the customer, information on a departmental store, information on the product. Because this is one example which I go for like tracing the criminal. Other information is like suppose suppose a customer has taken one material and unfortunately the date is expired. So he want a refund for that. So what he will do? He will take the bottle, go to a departmental store, and departmental store will scan to check when the bottle was purchased. If the bottle was purchased before that, okay, then they will give the refund, otherwise they will not give the refund. Because if the bottle is purchased 1 year back, then the date is expired, then they will not entertain the claim. But if the bottle was purchased recently within 2-3 days and has expired, then they will have to give the replacement or he may claim the things. So these are all the examples of POCO. Okay. Now see here, we have seen our why designs are there. Hello, are you able to see?
Yes.
Hello? See, each and every connection is different. Why it is designed so? This is a POCO only. Like mouse will not enter here. Like printer port will not enter here. So only right position only it will enter. Game joystick will enter here. Microphone is for this. See, even color coding is there. Microphone, we have this headphone symbol is there. This microphone symbol is there. Speaker symbol is there. Color is different. From this basis, customer, it is very easy to assemble the parts. So this is mistake proofing, error proofing, which is generally done at the CPU or electronic devices. So like AV is what? Appraisal variation. We saw AV appraisal variation. CPU saw process capability index, CTQ critical to quality, DPMO defect for within opportunity, DMAC define, measure, analyze, improve and control, DFSS design for Six Sigma, EV for equipment variation, FMEA for failure mode effect analysis. Then we have first pass yield. We have KPIs for performance indicators, LSL for low specification limit. What is the difference between specification limit and control limit? What is specification limit? How do you get USL and LSL, like upper specification, lower specification? How do you get that?
This talk the upper specification limit is talking the target above the target.
See,
where the lower.
See what happens, you know, specification is what? Specification is a drawing requirement. What is specification? Drawing requirement. If drawing is telling plus minus 0.1, then our upper specification, suppose it is 10 plus minus 0.1. What is upper specification limit? 10.1. What is lower? 9.9. So specification limit is defined by the drawing tolerance. Now control limits we have to find out. How we find out control limit? With the formula. CP is equal to tolerance upon 6 sigma. Okay, this is the formula. CPK is equal to USL minus X double bar upon 3 sigma or X double bar minus LSL upon 3 sigma, whichever is minimum. Okay, now this is USL LSL. Now
sorry, I'm lost. Yes? I lost behind by what you mean by specification from trying to differentiate the lower specification.
Specification is design specification. What is specification? Design, drawing. 10 plus minus 0.1 is design specification, right? Which is specified by design. Well, what is that? 10.1 is upper specification. 9.9 is lower specification, right? Specification is defined by drawing and control limits is defined by formula.
Thank you, sir.
Like we have X double bar, which is the average of X, which is the average of X bar. Okay. So we have upper specification. We have CP and CPK. CP process capability and process capability index. What is CP? CP is tolerance upon 6 sigma. Tolerance means specification. Our specification is plus minus 0.1. So what is our tolerance? 0.2. 0.2 upon 3 sigma. Standard deviation. Sigma is standard deviation. And what is CPK? CPK is upper specification limit minus X bar average, X double bar divided by 3 sigma, or X double bar minus lower specification limit upon 3 sigma. So this is the thing. We have MSA also. What is MSA? Measurement system analysis. What we saw in MSA? We have accuracy, we have precision,
Hello,
we
sir.
have repeatability,
Hello, sir.
we have
Can you hear me, sir? Hello, sir.
Yes, sir.
Hello.
Yes.
Please, can you differentiate CP and CPK?
See, CP is process capability. Formula is tolerance. What is tolerance? Plus minus 0.1 means total is 0.2. Now what is CP? Process capability is equal to 0.2 tolerance, which is 0.2 divided by 3 sigma, 6 sigma. Okay. And CPK is index. Index is calculated by upper specification limit minus X double bar divided by 3 sigma or X double bar minus LSL upon 3 sigma, whichever is minimum. Okay.
Okay.
Now,
Thank you.
VOC is voice of customer. How we collect the voice of customer?
Sorry, help us with the voice of customer, sir. So, voice of customer. Can you help us? I want a real understanding of voice of customer. What is it really mean?
The voice of customer is what customer want. How we collect what customer want? Through customer interest, we can take the feedback of the customer. Right? Feedback form we can fill. Online we can meet the customer. We can understand his requirements. Right? So this is voice of customer. Now what is voice of process? Process is stable or not. So CPK and CP is voice of process, which will show me where my process is running. So hope everyone is clear of. If you have any doubt, I can explain it again on the back, going on the back slides. So we have covered POCO, okay. We have covered Kaizens. 5S we have covered. We have covered 8 types of Muda. We have covered Muda, Muri, Murai. We have to remember only for Muda only downtime. Defect, overproduction, waiting. Okay. 8 types of Muda. Why we work on Muda? We have to save time, save money and save efforts. Simple example I have given here. The truck capacity is 4 ton and the load is 1 ton each. So total 8 boxes of 1 ton each. So this is Muri means burden beyond its capacity. Mura is unevenness. In 4 ton truck, 5 ton is kept and 3 ton is kept. So load is uneven. And this is waste. Muda is we are carrying 2 ton on 4 ton truck. So how many truck we are using? 1, 2, 3, 4. So total 4 trucks we are using of 16 ton capacity. 4 ton truck, 4 ton truck, 4 ton truck, 4 ton truck, 16 ton. For moving 8 ton of item, we are using 16 ton truck. So this is waste. Optimum is 4 ton truck and 4 ton load. 4 ton truck, 4 ton load. So 2 trucks. This is optimum. 3 we saw Muda, Muri, Murai. We saw the TPM losses, 16 losses. We saw the 5G approach. We saw the 5W2H solution. 7 QC tools we have covered. Japanese tool, lean thinking, lean principle. Okay. Before also I told Six Sigma work on variation. Lean tool works on waste, right? And that's why people combine it Lean Six Sigma. We are reducing variation also. We are reducing waste also, right? So if any question, please let me know. I will answer that. And we will be like, once you are comfortable, we will end the session.
Okay. Okay, sir. Hello.
Comfortable?
Hello, sir. Can you hear me?
Yes, I can hear you. Are you comfortable?
Okay.
Oh,
Okay, I have a question I want to ask.
yes, please ask.
Can you? Okay. You talked of line balancing, line balancing.
Hmm.
Yeah, you talk of line balancing, and I have a challenge in that regarding to my previous process. We have to make a blend of mayonnaise. We made a blend of mayonnaise, and we transfer to buffer tank. And we have a filling line I take from buffer tank that to from buffer tank to the filling line and the packaging line. So at times the filling machine consume mayonnaise in the buffer tank. So we wait for some times for mayonnaise blend to be ready in the buffer tank. I just want to ask this question: how can we reduce that waiting time?
So which is your maximum time here? Mayonnaise making, blending.
30 minutes.
Okay, 30
30
minutes.
minutes, we are done with the,
See
yes.
what you are doing, you are blending mayonnaise in a buffer tank, right?
No, we have a machine that blend it, get it ready within 30 minutes, then we transfer to buffer tank. From buffer tank, we take it to filling line.
So can you give me the time of each process?
Okay, the filling line consume 15 minutes. We consume one batch of mayonnaise in the buffer tank, which is 500 kg.
No,
And
give in
mayonnaise
time.
blend. Okay, time of making a blend to buffer tank is 30 minutes. Filling time to take what is a blend tank and the packages is 15 minutes. So,
See,
so that is it.
your blending time is 30 minutes, right? And filling time is 15 minutes, right?
Yeah.
So you
Yes.
can have
Yes.
you can have two filling machines. Then your
Why are
line will
we going
balance.
to have two?
Because
Why
your
are we
cycle
having
time
two
because
filling
your
line?
cycle time of filling is less.
No, what I'm saying, we finish what is in the buffer tank with the mining that is ready. We finish it before we finish it very quick before they bring another one in the blend in the buffer tank, which we wait for 30 minutes before mining to get ready in the buffer tank.
See, you have one blending station and filling station, right?
Yes.
So blending station take 30 minutes, right?
Yes.
And filling station take 15 minutes, right?
Yes.
So, and the time is exactly double. 30 minutes is double,
Yes,
right?
exactly.
So
Yes.
there are two things where first of all is like your blending time take 30 minutes, right? Which you are doing outside,
Yes.
right?
Yes.
So why are you making that much quantity in one setup?
Maybe you don't understand, but do you understand me well? The quantity, this machine has the capacity of making that
Then
quantity. At
your
30
machine
minutes, you make.
capacity is not balanced, na sir. Your blending machine has higher capacity than the filling machine, right?
No, the filling machine consume everything in 15 minutes. But it takes 15 minutes for us to produce, to make mayonnaise available in storage tanks. So how can we make the machine balance and know that we can't wait idle?
Then you have
as
to
a,
then you have to increase the capacity of the buffer tank.
Okay, I get from what you just said. We need to have extra blending machine so that this one brings.
Yeah, when 15 minutes
five.
consumed, second lot is ready.
Yeah. Yes, I got it. I get it now. Okay,
See, those
I'm
two
okay.
ways are
Thank you.
there. Two ways are there. One is to increase the capacity of the blending machine or the tank, buffer tank, right? If you increase the
Yes.
capacity of the buffer tank, then what can you do? You can fill it for 30 minutes. First time will be wasted, but continuously you can feed it, right?
Yes. Okay,
So
thank you,
capacity
sir.
balancing. See, line balancing is time balancing or capacity balancing. If you're filling in 15 minutes, then you have to produce the buffer tank 15 minutes. That is the only thing.